Detection of the polysaccharide. In this presentation, we will discuss some topics related to the polysaccharide, including its introduction, properties, classification, food resources, experimental performance, related disorders, uses, function, modern technique, plus its importance. What is polysaccharide? Polysaccharide is basically a carbohydrate. Carbohydrate is the polyhydroxy of aldehydes and ketones. In the terms of definition, we can say that it is the type of carbohydrate which is a polymer made of chains of monosaccharides that are joined by glycosidic linkage. These are also known as glycans. The point which makes polysaccharides different from the other sugars is that it contains more than 10 monosaccharides and can be hydrolyzed into simple sugars. Examples of the polysaccharides. Polysaccharides have numerous examples, but here we have six of them, including starch, glycogen, cellulose, inulin, dextrin, and hyaluronic acid. Properties of the polysaccharide. Here we have some of the properties of the polysaccharide, in which one of them is the color and the taste. Polysaccharides are tasteless and colorless carbohydrates. The second property is about the solubility. So that polysaccharides are slightly soluble in water but are more soluble in ether. About the crystal formation, so polysaccharide does not form the crystals on the desiccation. Here is the general formula for the polysaccharide. And about the hydrolysis, these are the higher molecular weight carbohydrate which breaks down into a monosaccharide or a product related to monosaccharide on hydrolysis. Polysaccharide can be classified into two groups on the basis of the nature of their sugar. Those polysaccharides which have similar kind of nature are said to be homopolysaccharide. The examples of the homopolysaccharides are starch, glycogen, inulin, dextrin, cellulose, lignin, and chitin. And those polysaccharides which have dissimilar kind of sugar in it are said to be heteropolysaccharides. The examples of the heteropolysaccharides are agar, gums, hemicellulose, pectin, and heparin. Starch. Starch is the polymer of the glucose and occurs in many plants, including crop plants like wheat and potatoes, as storage food. Starch is a soft white tasteless powder that is insoluble in cold water, alcohol, and the other solvents. It may be found in the leaves, stems, as well as roots, fruits, and seeds, where it is usually present in a greater concentration. The simplest form of the starch is the linear polymer amylose, and the branch form amylopectin. Starch on the reaction with iodine provides deep blue color. And about the structure, it is the polysaccharide comprising glucose monomers joined in a alpha 1,4 linkage. Glycogen. Glycogen is the reverse carbohydrate of the animal, hence it is called the animal starch. Glycogen is a multi-branch polysaccharide of the glucose that serves as a form of energy storage in animals, fungi, and bacteria. Glycogen has been shown in the plants which have no color chlorophyll system, example fungi and yeast. In the higher animals, it is deposited in liver and muscles as a storage material which are readily available as a source of energy. The molecular weight of the glycogen varies from 1 lakh to 4 lakh. It is not readily soluble in the water and it forms opalescent solution. Glycogen on reaction with iodine gives red color. And about the structure, glycogen is a polymer of alpha glucose with alpha 1,4 glycosidic and alpha 1,6 glycosidic linkage. Cellulose. Cellulose is an insoluble substance which is the main constituent of the plant cell wall and vegetable fibers such as cotton. It is a polysaccharide consists of the glucose monomers. Cellulose is not hydrolyzed readily by the dilute acids, but heating with fairly high concentration of the acid yields the disaccharide cellobiose and D-glucose. It is very stable insoluble compound. It is the main constituent in the plant cell. Human cannot digest cellulose, but it is important in the diet as a fiber. On reaction with iodine, cellulose gives no color. About the structure, cellobiose is made up of two molecules and D-glucose linked together by beta-glucosidic linkage between carbon 1 and carbon 4 of adjacent glucose units. Here the whole summary of the starch, glycogen and cellulose are present in the chart form, which highlights its important features. Importance of the polysaccharide. There are various importance of the polysaccharide, and here are the importance of starch, glycogen and cellulose. Glycogen. Glycogen has various importance in which some of them are a glycogen is an important buffer for the glucose level. Also, when an energy is required by the cells or the organism, glycogen serves as the critical energy source by providing glucose to the tissues throughout the body. Muscle glycogen is an important fuel source during an exercise, and also it plays an important role in the regulation of blood sugar and homeostasis. About the starch. Starch is manufactured in the green leaves of the plant from excess glucose produced during the photosynthesis and hence serves the plant as a reserve food supply. Starches also act as a source of energy. Starch foods are an important source of energy. After they are eaten, they are broken down into glucose, which is the body's main fuel, especially for our brain and muscles. Starches also act as a source of nutrient. Starchy food provides important nutrients to the diet, including vitamin B, calcium, folate, and iron. And about the commercial value in the commercial food world, stars help baked goods on every front. They help dough and batter adapt to processing equipment. Cellulose. Cellulose provides rigidity to the plant cells. The high tensile strength of the cellulose fibers in the plant cell wall is responsible for maintaining the shape and rigidity of the plant cell. Cellulose is an important component of the plant cell as discussed earlier. On the other hand, cellulose is also good for the intestine and it is the most abundant of all the carbohydrates, accounting for over 50% of all the carbons found in the vegetable kingdom. Polysaccharide plays a vital role in the metabolism of our body, so it is essential for us to make use of it in our daily diet. Starch, the plant food storage reservoir, are present in the cereal grains including wheat, barley, oats, corn, etc., and their products such as bread, pasta, cookies. Plus, also found in potatoes, yams, and legumes. Glycogen, the animal storage reservoir, are present in the shellfish, animal liver, and some fruits like banana, dates, papayas, and apples. Cellulose are present in whole grain, leafy vegetables, beans and lentils, and inulin are present in wheat, onion, chicory roots, which is a food additive. The experimental performance for the detection of the polysaccharide required two tests. One of them is the Molish test, which is for the detection of the carbohydrate, and other one is iodine test, which is for the detection of the polysaccharide. Knowledge test is for the detection of the carbohydrate. The whole mechanism of the knowledge test will be explained by showing a video. Instrument required for knowledge test are test tube stand, a test tube holder, a measuring cylinder, and a beaker containing a sample. The reason used in this test is 1% alcoholic alpha naphthalene and concentrated sulfuric acid. Take a test tube and hold it firmly with a test tube holder. Add 2 ml of the sample. Then add 1 to 2 drops of alcoholic alpha naphthalene. Shake the tube well so that the mixture can mix. After this, carefully add 2 ml of concentrated sulfuric acid from the side of the test tube. There is a formation of a purple violet ring at the junction of the two liquids. This indicates that carbohydrates are treated with concentrated solution. It uses two molecules of water and form sulfuride derivatives, which combine with alpha naphthalene to give purple colored ring at junctions of two solutions. When knowledge test becomes positive, then another test which will be performed is the iodine test, which is for the detection of the polysaccharide. The instruments and the reagents required for the iodine test includes sample solution, acidic iodine solution, which is basically potassium iodide solution, a test tube, and a test tube holder. The procedure of this test is that take 2 to 3 ml of a sample solution in a test tube and add few drops of iodine solution. The observation will be that the appearance of blue-black or a purple color indicates the presence of the polysaccharide, but if there is the presence of other colors such as yellow, orange, etc., this indicates the absence of the polysaccharide.
Uses of polysaccharide, glycogen. When the body does not need to use the glucose for energy, it stores it in the liver and the muscles. This stored form of glucose is made up of many connected glucose molecules and is called glycogen. When the body needs a quick boost of energy or when the body is not getting glucose from food, glycogen is broken down to release glucose into bloodstream to be used as fuel for the cells. Bacterial growth and yeast sporulation have also been associated with glycogen accumulation. Cellulose. Cellulose is mainly used to produce paperboard and paper. Cellulose comprises about 33% of all vegetable matter, 90% of cotton, and 50% of wood are cellulose and is the most abundant of all naturally occurring organic compound. Non-digestible by man, cellulose is a food for herbivorous animals, example cows, horses, because they retain it long enough for digestion by microorganisms present in the alimentary tract. Of great economic importance, cellulose is proceed to produce papers and fibers and is chemically modified to yield substance used in the manufacture of such items such as plastic, photographic films, and rayon. Other cellulose derivatives are used as adhesive, explosive, thickening agents for food and in moisture proof coatings. Starch. Most commercial starch is made from corn, although wheat, tapioca, and potato starch are also used. Aside from their basic Nutritional uses: starches are used in brewing and as thickening agents in baking goods and confection. Starches is used in paper manufacture to increase the strength of paper and is also used in surface sizing of paper. Starch is used in the manufacture of corrugated paper board, paper bags and boxes, and jumped paper and tape. Large quantities of starch are also used in textile industry as wrap sizing, which imparts strength to the thread during weaving. Related disorders: glycogen disease. There are at least 13 types of glycogen storage disease. Doctors know more about some types than others. Glycogen storage disease mostly affect the liver and the muscles. What is glycogen storage disease? Glycogen storage disease are a group of inherited genetic disorder that cause glycogen to be improperly stored in the body. Children with glycogen storage disease have a build of abnormal amount or type of glycogen in their tissues improperly stored in the body. Children with glycogen or storage disease have a buildup of abnormal amounts or type of glycogen in their tissues. What are the types of glycogen storage disorders? The main types of glycogen storage diseases in children are categorized by number and name. They include type 1 von Wright disease. This is the most common type of glycogen storage disease and account for 90% of all glycogen storage disease cases. Type 2 Pome's disease acid maltase deficiency. Type 3 Cory's disease. Type 4 Anderson's disease. Type 5 myocardial disease. Type 6 Her's disease. Type 7 Torrey's disease and type 8. What are the causes of glycogen storage disease? Glycogen storage disease are caused by a genetic enzyme defect that is inherited from both parents. Normally, enzymes help convert glucose into glycogen for storage. Other enzymes convert the glycogen back to glucose when quick energy is needed as an exercise. In a person with the glycogen storage disease, some of these enzymes are defective, deficient, or absent. This causes the buildup of abnormal amounts and types of glycogen in liver and or muscle tissues. Since glycogen storage disease are hereditary, the primary risk factor for is having a family member with this disease. What are the symptoms of glycogen storage disorder? Glycogen storage disease symptoms in pediatric patients depend on its type. The following is a list of common glycogen storage disease symptoms: low blood sugar, enlarged liver, slow growth, and muscle cramps. Symptoms of specific types of glycogen storage disease include type 1 von Wright disease, enlarged liver, and kidneys, low blood sugar, high level of lactate, fats, and uric acid in the blood, impaired growth and delayed puberty, bone thinning from osteoporosis, increased mouth ulcers and infection. Type 2 Pome's disease, enlarged liver and heart. In severe cases, muscle weakness and heart problems develop. In severe cases, infants may suffer heart failure by the age of 18 months. Milder forms of type 2 may not cause heart problems. Type 3 Cory's disease, swollen abdomen due to an enlarged liver, growth delay during childhood. Low blood sugar, elevated fat levels in blood, possible muscle weakness. Type 4 Anderson disease, growth delay in children, enlarged liver, progressive cirrhosis of the liver which may lead to the liver failure, may affect muscles and heart in late onset time. Type 5 Myocardial disease, muscle cramps during exercise, extreme fatigue after exercise, burgundy colored urine after exercise. Type 6 ninth and Hurry's disease, liver enlargement occur but diminish with age. Low blood sugar. Type 7 Torrey's disease, muscle cramps with exercise and anemia. What are the treatment of glycogen storage disease? Glycogen storage disease treatment will depend on the types of disease and the symptom. The goal of treatment is to maintain normal blood glucose level. This may be done with a nasogastric infusion of glucose in infants and children under age 2, dietary changes including in children over age 2, frequent small carbohydrate feedings are given throughout the day. This may include undercooked cornstarch. Uncooked cornstarch provide a steady, slow release form of glucose. Glycogen storage disease. Here's some pictures. Functions of polysaccharide starch. Starch is a dominant storage polysaccharide in most plants. Starch is manufactured in the green leaves of plants from excess glucose produced during photosynthesis and serve the plant as a reserve food supply. Starchy foods are an important source of energy. After they eaten, they are broken down into glucose, which is the body's main fuel, especially for our brain and muscles. Starch is the source of up to 80 of calories worldwide. Beside the significant role, starch have been used in food manufacture, cosmetics, pharmaceuticals, textiles, paper, constructions, material, and other industries. Highly resolving power and sharp zones are obtained in the food industry. Starch is used as a thickener, filler, binder, stabilizer in products such as soups, custard powders, pie fillings, sausages, and processed meats. Ice cream, sauces, gravies, baby foods, bakery products, and baking powders. Starch plays a very important role in achieving the desired viscosity in manufacture and processed foods like corn starch pudding, sauces, pie filling, and gravies. Starch can be used for analytical as well as preparative electrophoresis. Starchy food provide important nutrients to the diet including B vitamin, iron, calcium, and folate. Glycogen. Glycogen is an important polysaccharide and it is also known as animal starch. Glycogen is a storage form of energy in animals. Glycogen is an important fuel reserve for several reasons. The control breakdown of glycogen and release of glucose increase the amount of glucose that is available between meals. Hence, glycogen serves as a buffer to maintain blood glucose level. Glycogen is synthesized when blood glucose levels are high and broken down when blood glucose levels are low, making it an important buffer of blood glucose level. When energy is required by the cell or the organism, glycogen serves as a critical energy source by providing glucose to glycogen also very important for muscles. Glycogen is also very important for muscles. Muscle glycogen is an important fuel source during exercise. Inadequate glycogen availability results in reduced endurance, exercise capacity, and inability to continue exercise because of impaired excitation, contraction, coupling. Once glycogen stores are depleted, stored glycogen can be served as a fuel for following reason. Glycogen can be rapidly metabolized. Glycogen can generate energy in absence of oxygen. Brain depends on continuous glucose supply. Glycogen is a storage form of glucose and carbohydrate in animals and humans. Modern method and latest techniques of acid hydrolysis of polysaccharide. What is acid hydrolysis? In organic chemistry, acid hydrolysis is a hydrolysis process in which a protonic acid is used to catalyze the cleavage of a chemical bond via a nucleophilic substitution reaction with the addition of the element of water, for example, in the conversion of cellulose or starch to glucose. What is the acid hydrolysis of polysaccharide? Acid hydrolysis of disaccharide and polysaccharide produces monosaccharide by breaking the glycosidic linkage, either bonds between monomer units in the structure of the molecule. Acid hydrolysis of polysaccharide on sulfonated solid acid catalyst. Sulfonated solid acid materials such as sulfonated carbon catalyst are promising material as heterogeneous catalyst for the hydrolysis of esters and polysaccharide in water solvents. The catalytic active site is of sulfonic acid functional group compared to conventional strong acetic ion exchange resin catalysts. Sulfonated carbon material have less sulfonic acid functional group but higher catalytic activity for hydrolysis of polysaccharide per catalyst weight. Hydrolysis of polysaccharide with trifluoroacetic acid. For the total hydrolysis of polysaccharide, trifluoroacetic acid has important advantages over sulfuric acid. The reaction time is short and there is no need for conventional neutralization. A TFA is a volatile and can be removed by evaporation. Several methods have been developed depending on the substances to be hydrolyzed. Soluble saccharide, example polyosis, can be hydrolyzed with diluted TFA, while cellulose pulp and wood need treatments with concentrated TFA in homogeneous solution. All work is done by Sarah Abdul Hafiz, Muhammad Azim Ali, Muhammad Talha Shahid, Saman Sarfaraz. Thank you so much for watching.